Betelgeuse is keeping the research world in suspense after the red supergiant attracted attention in recent years with extreme fluctuations in brightness. Some experts believe that the explosive demise of this stellar colossus was imminent, but now the right shoulder of Orion is once again causing a stir. On one hand, there's a theory that Betelgeuse is rotating much faster than it should because it once devoured another star. On the other hand, there's an assumption that the stellar giant is still not alone. But even assuming that Betelgeuse is actually a binary star, how is it that the companion star has not yet been discovered? And how would its existence lead directly to the solution of a fundamental mystery? In our imagination, the sun often represents the ultimate in the cosmos. And no wonder, since in theory, our Earth would fit into our mighty mother star around 1.3 million times. Although the sun, with a diameter of almost 1.4 million kilometers, can confidently be described as impressive, we should not forget that there are far larger celestial bodies out there that would turn our central star into a puny dust particle. So, a quick reality check brings us back down to Earth in terms of astronomical facts, and we realize that Betelgeuse trumps the sun in every conceivable way. Located around 650 light-years away from us in the Orion constellation, this red supergiant's diameter is 800 times larger than that of the sun. This gigantic difference in size is also reflected in terms of luminosity. In fact, Betelgeuse shines a whopping 10,000 times brighter in visible light than our source of warmth and life. Or at least, it actually did. But even in space research, the principle apparently applies that exceptions confirm the rule. Approximately 5 years ago, Betelgeuse presented experts with a huge mystery when it dramatically lost brightness within a few weeks. In fact, the stellar dimming was so pronounced that it could even be seen with the naked eye in the night sky. In principle, periodic brightness fluctuations are quite normal for Betelgeuse, but in this case, it darkened much faster and more intensely than usual. A brief aside, the astronomical unit of magnitude indicates the apparent brightness of a celestial body, and the smaller the magnitude value, the brighter the object appears to us. While Betelgeuse, with an average luminosity of 0.3 to 0.4 magnitudes, is actually one of the 6th to 7th brightest stars in the entire sky. In December 2019, it darkened to 1.1289 magnitudes and consequently fell to the 21st place in the brightness table. Is Betelgeuse about to become a supernova? Consequently, experts had to look for explanations for this unexpected development, and since Betelgeuse, as a red supergiant, is approaching the end of its stellar life anyway, the suspicion was briefly raised that its brightness drop was connected to an imminent supernova. When it's not experiencing a mysterious dimming, Betelgeuse already shines 10,000 times brighter than the sun. However, as soon as it bids farewell to the cosmic stage in a violent explosion, researchers expect it to experience a 16,000-fold increase in its current luminosity. In the course of this, Betelgeuse would reach an apparent brightness of -9.5 to -1.5 magnitudes. Some experts believe that the celestial body will then appear as bright as the full moon, and it should even be easily recognizable during the day. But when exactly we can expect this radiant spectacle is a completely different question. In fact, most experts have now abandoned the assumption that the supernova will occur in the foreseeable future. What was at times interpreted as a harbinger of a primal spectacle turned out to be a massive plasma eruption. In the course of follow-up observations, this produced a no less massive dust cloud, which darkened the star by almost 2/3 for our earthly eyes. As mentioned earlier, Betelgeuse has reached the last stages of its life cycle and regularly loses large amounts of stellar material. This material is transported to the surface by convection currents from the interior and ejected. But in the same breath, Betelgeuse also experiences 400-day cycles of expansion and contraction, and experts estimate that it was the combination of strong convection and expansion that caused the plasma eruption to be 2 to 3 times more intense than usual. If we draw the bow back to the solar comparison, we see that Betelgeuse is ahead this time as well. The rate of mass loss during this event was about 30 million times higher than for our Sun. The bottom line is that the ejected plasma likely cooled in space and eventually condensed into a gigantic dust cloud. Since this happened to be in the line of sight between Earth and the red supergiant, it appeared to us as a huge veil that apparently darkened the star. The rotation puzzle. Has Betelgeuse swallowed up another star? But Betelgeuse wouldn't be Betelgeuse if it didn't have a few more puzzles in store for astronomers. For example, images taken by the coupled radio telescopes of the ALMA observatory a few months ago suggested that it is rotating at a crazy speed for a red supergiant. In detail, the rotational speed is more than 5 kilometers per second, which is 50 times higher than would be expected for a representative of this spectral class. In this context, Betelgeuse completely turns the stellar scheme on its head. Stars actually tend to slow down as they expand. In this regard, Jing Ma from the Max Planck Institute for Astrophysics in Garching, Bavaria, points out that Betelgeuse is actually the only known red supergiant thought to rotate so quickly. More specifically, the corresponding speed is attributed to the bipolar structure of the surface. One half shows a blue shift, while the other shows a red shift of several kilometers per second. But what explanations do astronomers have for this surprising rotational behavior? The first theory is based on the assumption that Betelgeuse is a cosmic cannibal. In other words, when it expanded into a supergiant around 100,000 years ago, it may have swallowed a companion star similar to the Sun. In this scenario, the absorption of so much mass caused the swallowed star to transfer the angular momentum of its orbit to the outer shell of Betelgeuse, thus accelerating its rotation. While this hypothesis was tested in a computer model, tangible evidence for it has also been collected. Images taken by the Herschel Space Telescope several years ago showed that 2 zones of ejected stellar material lie dormant on one side of the supergiant. These shell-shaped structures were interpreted as harbingers of the approaching supernova explosion, but they are also located almost exactly at the distance expected after a stellar cannibalism incident. There are other possible explanations as well. Ma's research team points out that the surface of the star is adorned with gigantic bubbles of rising and falling plasma, which can cover a large part of its visible outer shell. This is precisely the crucial point because the rapid movement of these plasma bubbles can also produce the aforementioned red and blue shift of the radio emission. In other words, it's possible that Betelgeuse is not actually rotating too fast, but rather creating a kind of optical illusion. If a very large convection bubble or a group of them is moving towards the observer and another is moving away from him at the same time, even a star that is not rotating at all can appear to be rotating extremely fast. Indeed, a recent analysis of the ALMA data in combination with an astrophysical model showed that this explanation is anything but far-fetched. On the contrary, according to MA, there is a 90% probability that the maps generated in the simulation will be incorrectly interpreted as high rotation rates. This is primarily due to the low resolution of the ALMA images, which distorts the true characteristics of the movements on the stellar surface. So at present, it's not possible to say with absolute certainty how fast Betelgeuse really rotates and how likely the scenario of the swallowed star is. But what we can say is that the evidence is mounting that the red supergiant is not alone after all. Does Betelgeuse have a companion star? As mentioned earlier, the brightness and surface of Betelgeuse pulsate in a cycle of about 400 days. Well, actually, the red supergiant has still not recovered from the gigantic plasma eruption of 2019, and the reverberations of the eruption continue to create rapid oscillations in its interior, while the surface is still vibrating like an oversized jelly. According to astronomers, it will take several years before the star finds its way back to its normal rhythm. However, in addition to its 400-day pulsation, Betelgeuse also exhibits a secondary longer brightness fluctuation that occurs over a cycle of 2,170 days, or almost 6 years. But the reasons behind these long periodic fluctuations remained unclear for a long time. In order to finally change this, Jared Goldberg and his colleagues from the New York-based Flatiron Institute recently devoted themselves to the task of thoroughly re-examining all of the observational data on Betelgeuse. Indeed, the new analysis revealed a number of unexpected anomalies. These begin with the fact that the 6-year cycle in the star's light curve is subject to a different rhythm than the subtle 400-day pulsations. In detail, the long periodic fluctuations are shifted against the rhythmic pulsation. Beyond that, however, the experts could not register any accompanying phenomena that would be associated with causes such as rotation sequences, magnetic field effects, or convection currents. Ultimately, the experts came to the conclusion that there is only one potential explanation for the long-period oscillations that has no fundamental flaws, namely the existence of a smaller companion star. Conversely, The strange 6-year fluctuations would thus reflect the orbits of the companion star. As soon as the stellar companion is behind Betelgeuse, as seen from Earth, the secondary period is at its lowest brightness. However, when the companion is next to Betelgeuse, the luminosities of the two celestial bodies combine, and the brightness reaches its maximum. At the same time, the companion star could also act as a natural dust shifter, influencing the distribution of the dust clouds, and thus playing an additional role in Betelgeuse's brightness changes. So far, so plausible. But how is it that the companion star has not been detected yet? Well, the answer to this question probably lies in its low mass. According to the researchers' calculations, it weighs only about 1.7 solar masses. Betelgeuse, on the other hand, has almost 20 solar masses. Furthermore, the companion star is likely to orbit its much larger partner quite closely, at a distance of only 2.43 Betelgeuse radii, to be precise. As a result of this configuration, the companion star is significantly outshone by its more imposing counterpart, and the brightness fluctuations and pulsation of Betelgeuse further complicate the task of detecting the companion's traces in the light curve. And even though the chances of spotting the companion star with today's telescopes are, to put it mildly, modest, the experts now want to apply for observation time at some of the larger telescopes. In doing so, they hope to uncover further evidence of the stellar partner's existence and possibly even clarify what kind of star we are dealing with here. The question of what kind of button you are dealing with under our video is quickly resolved. Feel free to click on the thumbs up and subscribe now to stay up to date. From now on, we'll see you soon.